Hi, Timothy Unkert here. In this video, I'm going to create a program in C that allows the user to input an upper limit. And what we're going to do is find all the prime numbers up to including the user input if that number is indeed prime. Okay, so what I'm going to do is I'll include some of the standard preprocessor directives to get started. And then we'll create our main function and we'll get coding. Okay, so the first thing I want to do is create a variable to hold user input for the upper limit. Okay, and I want to also create some index variables for the loops. Okay. And so what I'm going to do is let's create some of these. So we'll create all integers here. So we'll have an upper limit and then an I, a J, and a K for different loops. Okay. All right. The next thing is I'm going to set K because I'm going to have that in a while loop. I'm going to set integer K equal to 0. So we'll just say K equals 0 here. The next thing after I'm going to do that is I'm going to create a Boolean to hold the result of whether it's prime or not. So let's create a Boolean to hold result of whether it is prime or not. Okay, so what I'm going to do, just underscore bool, call it is prime, and we'll just declare it. We won't initialize it just yet. Okay, so the next thing I'm going to do is give instructions to the user to take in a value. So let's make a comment that we're giving instructions to user to enter upper limit here, and we'll do a printf, something like enter a positive integer to be the upper limit. Do a colon and a space, and I'll take out the new line here. All right, and then we'll go down, and the next thing that I want to do is I want to scan in the upper limit. So let's take in user input and place in variable. Okay, so we'll say we'll do a scanf here, %d, because we're taking in an integer, and then an ampersand and upper limit. Put a colon there. I also want to create an index for the value I'm putting in the array. This is how I'm going to store values in my array. So I'm going to say int array, or let's make a comment first. So we'll create index variable for array and initialize it to 0. Okay, I don't have to put a semicolon in the comment. I don't know why I did that, but so I'm going to say int, and let's call this array index, set it equal to 0. Okay. All right. The next thing I want to do is create an array to put the prime numbers into. So let's make a comment. We're going to create an array to put the prime numbers into. So I'm going to say int prime array, and then we're going to give it up to the upper limit. Now, you probably do this in a better way, and if you think you can, make a comment in the comments below. But we're going to allot that much space in memory in case every number was prime, which they will not be. So maybe there's a better way you could do this. Again, comment in the comments below if you think there is. Then we're going to run a nested loop, which isn't great from a big O standpoint, but we're going to do it. So we're going to run a nested for loop. This is big O of n squared, so it's not great, but let's do that. So we're going to say 4, and then we'll set I equal to 2. I is less than or equal to the upper limit, and we'll increment I throughout the loop. And then what we're going to do is we're going to do another loop where j is equal to 2, and then j is going to be less than or equal to the upper limit, and we'll increment j each time through the loop. And what we'll do is when we're going through this loop with j, we're going to determine if I is divisible by a number other than 1 and itself. If it is, then it's not a prime. So it won't be a prime at that point. So, if so, we'll set is prime Boolean to false, or in this case, 0, right? So the way I'm going to do that, I'm going to say if I modulo j equals 0 and j does not equal I, well then, it's not a prime number. So we'll say is prime is equal to 0. And then what we need to do is we need to break out of this for loop, okay? So we're going to do a break. Otherwise, we will say that is prime equals 1, which is true. And we won't need to break, okay? So in the larger for loop, each time we'll run through the loop here. In the larger for loop, we'll say if is prime double equals 1. So if it's true, what we're going to do is then we're going to append I to the array. And we're going to do that by saying prime array and put in the array index, which was set to 0 initially, equals I. Okay. Now, after we put one item into the array, we need to increase the array index by 1. So we need to increase the array index by 1. Okay, to do that, we're going to do array index plus equals 1, just like that. Okay. All right, so once we get out of this larger nested for loop thing, what we're going to do, let's make another comment here. Let's comment that we want to loop now through the prime array. So loop through the prime array. And yeah, what did I call it? Did I call it prime array? Am I doing this right? Yeah, loop through the prime array and print out the numbers, okay? So before we start that loop, I'm going to do a printf. And I'm going to just simply say the prime numbers up to and including percentage %d, which is going to be the upper limit, r, put a colon there, and we still keep the new line characters. I want to list them below. And I'm just going to pass in the upper limit here. And then I'm going to use a while loop. So I'm going to say while k is less than the array index, I'm going to do another printf here. So we'll do another printf. And let's just do %d, keep the new line character because I want 1 on each line. And we'll do the prime array at index k. And each time through, we'll increment k by 1. So it will eventually we won't get into an infinite loop. That's the concern that I have. Okay, so let's open up the terminal here. Let me increase the size here for this. Go to settings and get this nice and large so you can see it. Bring it up to 20. Okay, so what I'm going to do is first compile this. So let's see, what did I call this? Is prime.c. Okay, so let's do is prime.c. Everything compiled well, and we'll run it /a.out. Okay, so what is the upper limit? Let's do 40. And so you see here the prime numbers up to and including 40 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and 37. We could run it again, let's say do 100, and we'd get the prime numbers up to 100. So the program seems to work. I hope you found this video helpful and interesting if you're trying to learn some C stuff, or just interesting in general about prime numbers. If you did find it interesting, please give it a like, as it will help get out to more people. I also want to thank you for watching, and if you haven't subscribed, consider subscribing, as it really does help the channel grow. I want to thank you for watching, and I hope to see you in the next one.